Thanks, Harry. First, before I get started, a little bit about Antel Biosystems. We are a small research and development diagnostic laboratory in Michigan in the U.S. Our parent company is North Star Cooperative. They market semen in a 3-state area in Michigan, Wisconsin, and Ohio. They also run an animal recording agency or milk recording division as well. Our primary goal as far as Antel is to develop diagnostic solutions for dairy producers, and it includes milk, blood tissue analysis, or whatever we can come up with, again, to solve solutions for our dairy producers. First, before I get started, I certainly have to acknowledge IDEX on 2 levels. One, for allowing Antel to be involved in the evaluation of several prototypes during the development of this test. And then finally, for the privilege of presenting the early data and what I think is going to be the final prototype for this test. I'm going to talk a little bit about the importance of reproductive efficiency in dairy herds, and that's in this group is preaching to the choir. But as I was reviewing the web, I found this article of extension article at Michigan State University. The information is listed there on the bottom. It'll also be on the slideshow. But if you get a chance to look at it, it's pretty interesting. But in this study, they looked at about 90 dairy herds, large dairy herds in California. And what they did was they modeled the dependence of cow productivity and cow return against pregnancy rate, 21-day pregnancy rate. In the U.S., 21-day pregnancy rate is a common factor for the analysis of reproductive efficiency. It's defined as the number of pregnancies achieved in a 21-day period divided by the total eligible cows. But I think for our purposes, what we are particularly interested in is to improve pregnancy rate, pregnancy detection, or at least the ability to accurately and timely identify open cows is very important for pregnancy rate. When we look at pregnancy diagnosis, I think traditionally we're looking at palpation, more recently ultrasound. Ultrasound's very accurate. If you look at the advantages, it's, like I said, accurate. It's real time. You get that information upon palpation, and also you get other information besides pregnancy. You get information on cystic ovaries or reproductive tract health, twins, fetal sex, and things like that. So you get a lot of information with ultrasound. However, disadvantages are it is very labor intensive. You have to sort the animals, you have to restrain the animals, and also requires a lot of technical expertise to do ultrasound. I have that disrupted to pregnancy up there. I know it's kind of a touchy subject, but actually we run blood pregnancy assays, and there's several clinics that send blood samples to us with the idea that when you get some embryo transfers that are of high value, they'd rather actually use the blood test in early pregnancy than ultrasound, again acknowledging the fact that it is a potential case for disrupting pregnancy. More recently, there's been available blood chemical assays, whereas the 3 listed there, progesterone, early conception factor, and estrone sulfate, kind of fell by the wayside because of the lack of reliability and lack of practicality. The more recent one is the pregnancy-associated glycoprotein blood assay. The advantages of the glycoprotein assay is it's accurate. Sensitivity is reported generally above 98%. That's sensitivity for detection of pregnancy, and specificity anywhere between 90 and 97%. The other advantage is it's very simple. You don't require the technical expertise for pregnancy diagnosis. However, it has the same disadvantages that you have to restrain the animals or sort, restrain to actually pull the blood sample to do the pregnancy diagnosis. In order to solve the labor-intensive aspect of pregnancy diagnosis, I think everyone in this room has probably been looking for a milk biochemical analysis that we can apply to the milk recording industry. There's been several attempts in the past, progesterone and estrone sulfate, but as with serum testing, those have been proven fairly unreliable and unpractical. And there has been 2 reports recently on the detection of PAGs, pregnancy-associated glycoproteins, in milk. And unfortunately, in those previous studies, they were only effective after day 150. And I'll get back to that on one of the figures. But anyway, day 150 carried calf and out, they were able to detect pregnancy in those previous studies. So let's cut right to the chase. I'm just going to go ahead and describe quickly what this test is about, and then we'll get into some data, and then eventually integration into the milk recording system. But the IDEX milk pregnancy test is accurate, has high levels of sensitivity and specificity throughout lactation. I don't want to confuse everybody there with the days post-calving, but that is days post-calving when you can actually start to apply this assay. But as you'll see, this assay is effective throughout early lactation and or early gestation, mid and late gestation. The actual day of detection for the commercial kit it will be confirmed, but you'll probably see data in bins where you're able to look at accuracy within various categories of gestation. It is a very robust platform, ELISA. It's been around for years, and the results are available in 3.5 hours. This certainly is an opportunity, like we've been discussing, to add value to the milk samples that we regularly collect, and so this is a great opportunity for milk recording organizations. And once we integrate this into the DHI system, I think you'll see that there's a lot of opportunity actually to improve reproductive efficiency with the use of the milk pregnancy test. At least I hope that's what to portray. Here's the kit. The kit is a 96-well ELISA strip well format, so it's the plates are loaded with 12 8-well strips, so that will reduce wastage. It's effective on whole DHI samples, preserved samples, so there's no sample processing required. Simply go ahead and pipette into the 96 wells. Like I said, 3.5 hours to results. The reagents are ready to use, so there won't be any mixing involved, simplifying the assay in the laboratory. And it uses standard ELISA equipment, and it does, again, its target antigen is the pregnancy-associated glycoproteins. A little background on the pregnancy of glycoproteins. Again, it is the target antigen, but they are expressed in the trophoblastic binucleate cells of the placenta, so hence they are associated with pregnancy. It's a subgroup. It's not a single protein. You got to remember that. This is a subgroup of proteins of about 22 plus proteins that are expressed temporally or variably expressed throughout gestation. The function of these proteins have been proposed to be anywhere from immunomodulation, support or a luteotroph for the support of the CL, as well as the formation of the placenta and function of the placenta. And I think that's very important. I'll get back to that later. But by having an objective measure of PAGs in the milk sample, and we get that in the animal recording system, there might be some possibilities for research and looking at the variations and what those variations might mean when it comes to pregnancy wastage. Looking at PAG levels in the serum as they are identified or measured by the IDEX serum kit, you see that on the horizontal axis is days post-breeding through gestation and again after calving, and on the y-axis is the sample to negative ratio. So after the ELISA is conducted, you subtract the negative control OD from the sample OD and you come up with an ELISA score. So you can see quickly for the set of PAGs that this assay is measuring, they rise quickly start at about day 15, 16, they rise quickly up to day 28. They take a little pause there between 40 and 90 days and then again rise up until late gestation. This is a profile of just one animal. When you look at a group of animals and you look at averages, you actually do see a decline in serum levels between that day 40 and 90 range, and that's going to be important when I show you the profile of milk PAGs throughout gestation. And looking at the half-life or the clearance of PAGs after calving, on the right-hand side of the graph there, you can see that PAGs are cleared from blood with a half-life of about 7 to 9 days, and they're completely cleared from the blood within the normal voluntary waiting period in dairy herds. So, specifics about the assay. Again, it's a sandwich ELISA. Coated plates, add your sample. The first incubation step is 2 hours at 37 degrees C, followed by incubation with a biotinylated detector antibody that also binds the PAGs, followed by conjugate, streptavidin conjugate, which allows the improved sensitivity of the assay, which is another 30-minute incubation at room temperature, followed by substrate for 20 minutes at room temperature. Stop the assay and read the assay at 450. And again, the signal is the sample control, or the sample value minus the negative control value. So This is the temporal study that was done on milk PAG levels. 5 to 13 animals were sampled at each of those time points, and the average response is plotted on the graph along with the standard deviation. That blue line down there is the detection limit or the threshold for positivity. And again, recalling that serum graph, you can see that the correlation is pretty good. PAG levels in milk are first detected at about 24 days in milk, quickly rise to about 32 days, where they're clearly distinguishable from baseline levels. They drop between day 40 and 90, and then eventually rise up until the end of gestation. And as you recall, I mentioned those 2 previous studies on PAGs in milk, and again, look at where 150 is. So if you look at where 150 is and a score of 2 on this particular assay, you can see what IDEX was able to do. They were able to amplify the sensitivity of that assay so they can bring those PAG levels above detection limit, and that was probably one of the major challenges when looking at using PAGs for detection of pregnancy using milk samples. It's also important to know what the half-life of these PAGs are, or the clearance rate in PAGs are in milk samples. So to do this, 134 cows were sampled after calving and before breeding, and the results are displayed here on this graph. On the horizontal axis, you have days post-calving in increments, and again, the sample minus negative value for the PAG score. And so you see that as in serum, PAG levels decline with about a half-life of 7 to 9 days. They're completely cleared from milk samples by 60 days. So that's typically within the voluntary waiting period. Plus, when you look at breeding, you're looking at another 28 days. So clearly, this will not have any interference in subsequent diagnosis in the subsequent breeding program. Okay, so looking at the performance of the assay, the first herd, again, very early results of the final prototype assay was a dairy from New England. 192 samples, cows were sampled. All samples were at least 60 days in milk and greater than 40 days post-insemination. The graph there on the right, days post-breeding in increments with the PAG score on the left. Of the 156 pregnant cows in this herd at that time, the IDEX milk pregnancy test identified 155 for a sensitivity of 99.4%. You will notice that there's a recheck zone in there, and there will likely be a recheck zone to cover that gray area. And the recheck zone will help to actually improve accuracy at various increments throughout gestation. Also, of the 33, I guess, again, excluding the recheck zone, of the 33 open cows, as determined by ultrasound, the IDEX milk pregnancy test identified 33 for a specificity of 100%. This was a dairy in our neck of the woods, Midwestern dairy, 120 cows sampled, same format, greater than 60 days in milk, greater than 40 days post-insemination. And here you can see of the 107 animals that were determined pregnant by ultrasound, the milk pregnancy test detected 104 for a sensitivity of 97.2%, and of the 12 open animals, the pregnancy test detected 12 for a specificity of 100%. So there's not a lot of open cows. There shouldn't be when you go to a dairy herd, so you got to kind of search for open cows. And to do this, we looked at 290 cows from 5 geographically different areas. All of these cows were at least or greater than 60 days in milk and either hadn't been bred or bred greater than 40 days, but then were determined open by ultrasound or palpation. And you can see here, overall, the specificity was 96.7%. Within the ones, or let's say call them false positives, anything after day 90, the specificity was 100%. There was a lower specificity before 40 days, and that's certainly likely due to embryonic loss, protein wastage, and the fact that there would be residual PAGs after the loss of the pregnancy. So, I think from what I've seen of the additional data, and there's a lot more data coming in, that these results aren't going to change very much. I think it's time we start thinking about how we're going to integrate pregnancy testing into animal recording organizations. So I think if you look in the field, This assay particularly has application from early pregnancy detection all the way through confirmations and dry-off testing. So the fact that it has this versatility, I think, will allow for a lot of flexibility and scope in how we apply this particular testing program through milk recording organizations. And most dairy programs certainly have ways of pre-selecting cows for days carried calf, and we'd be able to identify those fairly easily. When you look at the laboratory, again, most laboratories are familiar with the ELISA format. Certainly this is a simple ELISA format, and it uses existing samples. So like I said, we will not have to, or you will not have to, process those samples before putting them in the assay. And as far as data processing centers, it's a 3.5-hour assay, so it's a rapid turnaround time. I don't think we will necessarily have to slow down data uploads or data processing. Certainly if we can turn those around on the same day. If you look at the production reports, there's usually a case or a point on there where you're actually adding reproductive test or pregnancy test data, so this will be a simple integration into the existing reports. But also with this, it's important to note that we will be able to do multiple test times at various times during gestation to add to the additional amount of information in the recording systems. I think what we'll plan on doing when we start to offer this is coming up with a hot sheet, something that's turned over very quickly and uploaded to the website so they have that data access as soon as we're done with the assay. And that will probably start listing open cows first, followed by the pregnant cows, but just to give them an idea of who needs attention right away. So conclusions, this isn't, it shouldn't be surprising. If we found PAGs in blood, they're going to be in milk. It just took an assay to actually be able to detect those PAGs. And so clearly this assay can detect PAGs in milk samples. Certainly offers us an extended a menu option for applying to our herd samples coming in our recording laboratories. For our producers, it's a hassle-free, cost-effective method of pregnancy detection that can be applied early, mid, late gestation. And again, I think with all this data entering into the system, give it some time. I think when you start looking at PAG levels or the PAG scores and trying to correlate the variation that we'll see in the future, or at least the changes throughout gestation, there might be some important correlations with pregnancy wastage that might benefit the dairy industry and improve reproductive efficiency in the future. So with that, thank you very much for your attention. If you have any questions about the commercial availability of this kit or the plans, you can visit Hannah at the booth downstairs. And if you have any technical questions, I'll be happy to answer them. Thank you.